AI learning tools face a fundamental question. Do they actually help people learn? Engagement is not learning. Usage is not mastery. Proving AI educational tools work requires rigorous measurement. This segment covers how to measure AI learning tool effectiveness, essential for building, buying, or evaluating AI education products. The AI Measurement Challenge. Traditional educational software had fixed content, but AI adapts to each learner. Every student gets a different experience. How do you measure effectiveness when the treatment varies? AI can also game metrics. An AI tutor could keep students engaged without teaching them anything. Engagement metrics without learning outcomes are dangerous. Metrics that matter. Learning outcomes are the gold standard. Can students do things they could not do before? Transfer to new situations indicates deep understanding. Retention over time matters. Learning that disappears after a week is not learning. Efficiency metrics complement outcomes. Time to mastery delivers real value. AI-specific metrics. Adaptation quality measures whether personalization helps. Scaffolding effectiveness measures whether students develop independence. Error. Handling quality matters enormously. When students make mistakes, does AI correct productively? Explainability affects learning. Students who understand AI feedback learn more. Bias and fairness. Measurement. AI learning tools can discriminate, disaggregate outcomes by student group, analyze AI behavior across groups, watch for stereotype reinforcement. Measurement methods. Randomized controlled trials isolate AI impact. A/B testing enables continuous improvement. Longitudinal tracking captures long-term effects. Building measurement into AI products. Measurement should be designed in, not added later. Separate engagement optimization from learning optimization. Build assessment. AI cannot game. Standards and certification. What Works Clearinghouse evaluates educational interventions. IST standards cover technology integration. No equivalent standards exist yet for AI-specific tools. Kazakhstan could develop AI education standards before other countries. First mover advantage in standard setting creates lasting influence. Key metrics to track: learning gain per hour, struggle to success ratio, help dependency trend, misconception detection rate, personalization effectiveness, long-term retention. The companies that measure rigorously learn faster. Measurement discipline creates better products and builds trust with buyers. Let me share specific metrics that AI education companies should track. Struggle to success ratio tracks productive challenge. Students should struggle sometimes. That is learning. But too much struggle indicates poor AI support. Help dependency trend shows whether AI builds or undermines independence. Students should need less help over time, not more. Misconception detection rate measures AI teaching quality. Does AI catch when students develop wrong mental models? Does correction work? Personalization effectiveness compares adapted versus non-adapted outcomes. If personalization does not improve results, it adds complexity without value. Long-term retention at 30, 60, and 90 days shows whether learning persists. Short-term gains that disappear are not real learning. Build a measurement culture from day one. The habit of asking, does this work, and how do we know, shapes every decision for the better. For your SMILE participation, generate 3 what-if hypothetical scenarios for new ways to measure AI learning tool effectiveness that do not exist today. Each should describe specific measurement mechanisms, data sources, and validation approaches. For each, state the what-if question, describe the measurement gap it fills, explain the technical approach, and identify potential gaming or manipulation risks. Post your 3 hypotheticals and comment on 3 peers' ideas, suggesting refinements or identifying measurement blind spots. Evaluate based on measurement rigor and innovation. Sample smile posting hypothetical 1. What if we measured learning durability by having AI tutors retest students on random past topics during future sessions, creating continuous retention data without separate assessments? Measurement gap. Current assessments measure learning at one point. We do not know how long it lasts. Technical approach. AI embeds review questions from weeks or months ago into current sessions. Tracks decay, curves per topic per student, adjust teaching based on individual forgetting rates, gaming risks. Students might study old topics before sessions if they know reviews are coming. AI might overtest, reducing learning time. Hypothetical 2, what if we measured transfer distance? How far from the training context students can apply learned concepts using AI-generated novel problems? Measurement gap. Current tests use problems similar to practice. Real learning means applying knowledge to new situations. Technical approach. AI generates problems that require same underlying concepts but in unfamiliar contexts. Measures success rate as context distance increases. Maps each student's transfer radius. Gaming risks. AI might generate unfair problems. Students might learn to recognize AI problem patterns rather than concepts. Hypothetical 3, what if we measured AI tutor effectiveness by tracking student performance in subsequent human-taught classes, creating longitudinal outcome data? Measurement gap. AI tutoring might help with AI tutoring, but not real-world learning. Technical approach. With consent, link AI tutoring data to school records. Compare AI tutored students to control group in later courses. Identify which AI approaches predict long-term success. Gaming risks. Selection bias. Students using AI tutors may differ in other ways. Privacy concerns with linking data sources. Rigorous measurement separates AI learning tools that work from those that just seem to work. Build a measurement culture from day one.